Okay, we've covered arithmetic topics. We've covered linear topics, meaning x to the first power. We've covered lines. We've covered factoring. Now it's time to look at radicals. I used to cover radicals and rational expressions in the same unit. And what I'm doing now is we're going to count the radicals unit as a 4A unit, and then we'll count rational expressions as a 4B unit. So I broke it up into two pieces. So we're not going to do all of it together. When I did all of it together, half the class would get like between 95%, 100%, and then the rest of the half of the class would get below 50% on the test. Okay? So I'm not going to lie that rational expressions and radicals, this is not something that generally comes easy to people. This is partly why you're taking this class. I knew that basically all of you would be able to solve 2x minus 3 plus 1 is equal to 6x minus 4. You like solving those things, right? You got used to doing that for a long time. That was Algebra 1, a little bit of Algebra 2. But the parts that you struggled with is when you got to radicals and rational expressions. And we want to kind of beef up your knowledge of those pieces so that when you get to college, you're going to be able to handle those topics and handle them well. So, in order to tackle this, we first need to tackle the idea of perfect squares. You don't have to memorize these, but trust me, it is a lot better if you could commit some of these to memory. Okay? 1 times 1 is? 2 squared is? 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10? 11? 12? Good. 13? 169? 14? 196? 15? And 16? 256. Those are your perfect squares up to 16. And we do go higher than that. 17 would be 289, 18 would be 324, 19 would be 361, 20 is 400, so on and so forth. I think that these ones are excellent for you to know. So I would encourage you to try to memorize them as best as you can. People who see those and recognize those generally have an easier time moving forward. Now, these are perfect squares, all right, x squared. We also want to talk about perfect cubes. Now, we just talked about factoring the sum and difference of cubes, but now instead of multiplying it twice, we multiply it 3 times. 1 times 1 times 1, 2 times 2 times 2, 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 is 25, times 5 more, 125. 6 times 6 is 36, times 6 more, 216. 7 times 7 is 49, times 7 more is 343. 8 times 8 is 64, times 8 more is 512. Those are perfect cubes. Honestly, if you know up to 216, you're probably pretty good, but I would say that these are nice perfect cubes to memorize. Okay. Now, finally, we will just go up to fourths. I won't do fifths and sixths, but we should know how to do perfect fourths as well. 1 times 1 times 1 times 1 is 1. What is 2 to the 4th? 16. 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 more is 81. 4 times 4 is 16, times 4 is 64, times 4 more is 256. And 5 times 5 is 25, times 5 is 125, times 5 more is 625. you can see how when you increase the power, the numbers get bigger really quick, don't they? And so that's why we're just going to look at those. So, perfect squares, perfect cubes, perfect fourths. We all good with that? All right, so our first goal with radicals is to be able to simplify radical expressions. And we say that a radical is not simplified if you can take a perfect root out of it. So this is a square root. And I gave you kind of a tough one to start. Let's start with an easier one. Does anybody know the perfect square that divides evenly into 28? So I look up here, which number in red divides evenly into 28? 4. How many times does 4 go into 28? So I have the square root of 4 times the square root of 7. So you pick two numbers that multiply to 28. They are 4 and 7. Okay. I put the perfect square first. And then I answer, what is the square root of 4? It is 2. So this becomes 2 roots of 7. Did people used to make like factor trees with this? I don't do the factor trees. I do this. I see a square root, I divide it up into 2 square roots. Do you know the perfect square up here that divides evenly into 48? If you don't know, you're going to have to divide on your calculator until you find one. It is 16. How many times does 16 go into 48? 3 times. So you have the square root of 16 times the square root of 3. What is the square root of 16? So this becomes 4 roots of 3. I have the square root of 125. Which perfect square up here divides evenly into 125? Want to take a guess? 25 goes in how many times? 5 times. So I have the square root of 25 times the square root of 5. So in this first step, you always have to have where this one times that one gives you this one. Okay? And one of them needs to be the perfect square. What is the square root of 25? So this reduces to 5 roots of 5. What is different about number 4? Now you're looking at a cubed root. So I do not look at these numbers here. I look at these numbers here. What is the perfect cube that divides evenly into 16? 8 divides evenly into 16. Agreed? So I rewrite this as the cubed root of 8 times the cubed root of what? 2. Because 8 times 2 is 16. What is the cubed root of 8? 2. So this becomes 2 cubed roots of 2. Number 5 is different because you have a 4th power, or a 4th root. So I look at these. Which number up here divides evenly into 162? 81 goes in how many times? Twice. So I have the 4th root of 81 times the 4th root of 2. What is the 4th root of 81? 3. So you get 3 4th roots of 2, which is probably something you've never written before, have you? Like that actually feels weird to write it with your hand. You're like, what is that? Okay. The cubed root of 81. I like this because 81 is a perfect square. 81 is also a perfect fourth. But 81 is not a perfect cube. Do you know the perfect cube that divides evenly into 81? So suppose you're in the situation where you're like, I don't know the perfect cube that divides evenly into 81. Then go ahead, you can turn on your calculator at that point, take 81 divided by 64. Does 64 divide evenly? No. Divided by 27. 81 divided by 27. Does that divide evenly? Yeah, it does. Looks like 27 goes in 3 times. You have the cubed root of 27 times the cubed root of 3. What is the cubed root of 27? So you have 3 cubed roots of 3. Yeah. Flipped over. We do through problem number 12 today. Number 8, the radical sign should go all the way across. Sorry about that. Radical sign should go all the way across. What's different about these problems? They have variables. Yeah, they have variables. And when they have variables, we just do the number first. Is 625 a perfect fourth root? As you look at your fourth roots, do you see 625 listed? What is the fourth root of 625? It is 5. And then we have x to a power, okay? What do you multiply by itself 4 times to get x to the 20th? X times x times x times x is x to the 4th, right? And x squared times x squared times x squared times x squared, that's x to the 8th. And so, Alex, you said if you multiply something out 4 times, what's going to give you x to the 20th is going to be x to the 5th. We look at number 8. Is 27 a perfect cube? What do you multiply by itself 3 times to get 27? 3. We have a y and a z. What do you multiply by itself 3 times to get y cubed? Just y to the 1. What do you multiply by itself 3 times to get z to the 6th? Z to the 2nd. And so that's that cubed root. Is 216 a perfect cube? Yep. What is the cubed root of 216? It is 6. X to the, what do you multiply by itself 3 times to get x to the 15th? X to the 5th. Yeah. Okay. We do 10, 11, and 12. We'll take a break there. So we're going to kind of put both pieces together. Notice in this one you have the square root, but is 32 a perfect square? It is not. And so what I'm going to do is I'm going to break it up into 2 radicals. And the first radical, I always put the perfect squares. The other one, I put the leftovers. Okay? Yes, so 16 is the perfect square. That multiplies to 32. So I put the 2 over here. Okay? Now I focus on x cubed. X cubed isn't a perfect square because x times x is x squared. And x squared times x squared, that's x to the 4th. And x cubed times x cubed, that's x to the 6th. So you see that there's nothing we multiply by itself to get x to the 3rd. So what I do is I reduce it to one that is a perfect square. So since x cubed doesn't work, I reduce it to x squared. That is a perfect square. So it needs to multiply to x cubed. So if I have an x squared here, what should I have over here? Just x. And then I move to my y's. Is y squared a perfect square? Yes, so it can go here, and I don't need anything over here. So, square root of 16, 4, square root of x squared, x, square root of y squared, y. And then you have root of 2x. That's your answer. For number 11, I noticed that 49 is a perfect square, but x to the 5th is not. So I'm going to set up two roots. Since 49 is a perfect square, it goes here. Is x to the 5th a perfect square? No, so I reduce it to x to the 4th. So what do I need to put over here? Just x. Is y to the 7th a perfect square? No, so I reduce it to y to the 6th. So I have to put a y over here. Square root of 49, square root of x to the 4th, square root of y to the 6th, y to the 3rd. And finally, our last one for today. 50 is not a perfect square. What's the perfect square that divides evenly into 50? So I have a 25 and I have a 2. Is x to the 4th a perfect square? Yep. Is y to the 3rd a perfect square? No. So I reduce it to y squared and I put the y over here. Square root of 25 is 5. Square root of x to the 4th is x squared. Square root of y squared is y, root of 2y. And that's your answer. If you would please look at your homework. So you can see that the first worksheet says simplifying, adding, and subtracting radicals. We're not going to be adding and subtracting today. That's something we're going to do tomorrow, okay? So you could just focus on problems 1 through 18, and then there's 3 on the other side, 19, 20, and 21. Those are the problems that would kind of help you. Don't feel bad if some of these become a little bit challenging for you. We're going to have time to practice them at the beginning of class tomorrow, and then look towards adding and subtracting, okay? So go ahead and take some time to look at those. And if you need to keep out the perfect squares and cubes and stuff, and I do this for you because people have asked for it in years past, I give you these numbers on the test. So is that good for you? I'll give you those numbers on the test, okay? So I'll let you be. I'll post the answer key up here, and I'll start to grade your tests.